Dr. Marshangizi here, their Science Moment. Which kind of art do you like more, sculpture or paintings? Now, there's not really going to be an answer to this per se, but there's a feature, a distinction between them, a big difference between them that's always pushed me to favor paintings more than sculpture. And it's that sculptures are almost always copies. Right? Whenever you've seen a sculpture in real life, almost always it's not the original. The original was usually something very small, relatively small, that could be in the studio, done by hand in a relatively small space. And then it's engineers using various different kinds of sort of tricks, clever tricks, to make copies of these at larger scales. I'm showing you here on screen sort of one of the kinds of examples of these kinds of tricks, but done for sculpture. So you have never seen, in fact, the original. Now, the original may have its own unique little bits of features, but if they've done a good job in copying, you're not going to notice. And at any rate, you've never seen the original. Almost always, you're seeing copies. Whereas, of course, you've seen many copies, photographs of art that you liked before. But a lot of the art that you've seen, if you've gone to art museums, is the art. It's the real deal. And it differs irrevocably from photocopies, from photographs. And why is that? And there's two main reasons. One is that even if, of course, you did a photograph of it and made it to scale and put it up on the wall, it's missing the three-dimensional features, because even though paintings are, to first order, flat, they're not. Most paintings have some degree of some subtle, and often very non-subtle, three-dimensional structure, depending on their strokes. Sometimes just incidentally the strokes, but it leaves an impact on you. Or often it's part of the intent of the artist, him or herself. The other is the specific colors and palettes used. And the specific colors and palettes have their own unique spectrum. They have their own spectrum that affects the eyes in very particular ways, and the artist was potentially using that effect, realizing that it has this particular look in normal kind of white lighting. When you try to take a photograph of that, supposing you don't even care about the small three-dimensional ridges and bumps, you lose that. Photographs, when you take the photograph, you are only getting an approximation of the spectrum. You're sort of shoving this full infinite dimensions of spectra. You're shoving it into RGB when you take the photograph, and then when you re-display it on a screen or in a printout, you're now displaying it in a few small elements with distinct spectra across the spectrum, just three typically across the spectrum. Now, so what you're going to see when you look at the result, either on paper or on photograph, isn't the same as what it would look like in real life, because it's not able, the camera is not able to do the same kind of processing that your eyes are doing with your cones, your retinal cones in your eyes. So you end up with something different. It isn't the same. And both of these are very, very difficult and possibly will never be the kind of thing that you can reproduce, so that I can end up with a actual copy that has the three-dimensional ridges down to the last three-dimensional ridges over there, and also the exact same spectral features as far as the human eye is concerned. Whereas copying sculpture, well, that's been done for thousands of years, right? But copying paintings is not easy, and that makes me more excited when I see the real deal. One wants to feel like this is the original. It's not just the fact that it's the original, but also there are unique bits of it that make it aesthetically different than any copy ever will. And that was your Science Moment. If you're interested in visual perception and color vision and three-dimensionality and seeing in three dimensions and things like this, see my earlier book, The Vision Revolution, on varieties of my discoveries in these fields. That was your Science Moment.